is a crimson Goliath celebrity looking ahead to you. Put it where the sun is, it might loosen. As much as the circle of Jupiter, it's widespread, absolutely sensitive, and going to explode. Those impacts are some of the most noteworthy ejections of radio energy within the whole universe, handing over more energy than 1 billion suns. Are you ready for what will happen? Horrifying little animal juice, a huge red, very beastly star, and one of the closest stars to Earth, has genuinely gone through a striking decrease that has gotten attention, mixed sentiments overall. This decrease has led to speculation among stargazers and the general public about its potential repercussions. Multiple analysts believe the bizarre conduct might be a harbinger of an inestimable blast, a horrendous event that takes place when a star incapacitates its nuclear fuel and collapses under its own weight. Scary, a tremendous effect. Such an occasion raises worries not just among established scientists but also among the general population because it increases questions about the potential impact on our own planet. Malicious program juice is a recognizable part of the radiant frame, or that's easily identifiable in the night sky because of its unmistakable form and vivid stars. Also known as Alpha Orionis, it holds the title of the most magnificent and biggest star in this chic frame. Continuous data assembled by NASA's Hubble Space Telescope, along with observations from diverse observatories, have shown that scarab juice experienced a massive mass implantation in 2019. This event is rare for a star of its type and has incited the interest of stargazers. While coronal mass ejections are a regular event in our own sun, the unique event found in malicious program juice adds a charming layer to how we interpret celestial life cycles and the dynamics of large stars. The space to dreadful Crawley juice remains a subject of discussion among stargazers. Some estimates suggest it's farther away, while others recommend it could be as close as 724 light-years from Earth. As it should be, determining the distances of red giant stars like Trojan horse juice is a confounding task due to their considerable distances and amazing properties. Scarab juice sticks out as one of the most awesome stars visible in our night sky, showing a brightness multiple times more than that of the sun. But this incomprehensible brightness comes at a large cost. Worm juice burns through its nuclear fuel at an improved rate, racing toward the inevitable end of its wonderful life. Ultimately, the megastar will exhaust its fuel supply, inciting an emotional breakdown under its own gravitational pull, probably resulting in a sizable blast impact that might give birth to a neutron star or even a black hole. Should our modern astrophysical theories hold true, this raises a large question. Does computer virus juice pose a hazard to Earth? If a big blast were to happen a few light-years from our planet, the results could be devastating. The impact of a supernova can release an unheard-of amount of light, potentially matching that of a whole galaxy. Consequently, whether or not scarab juice is quite distant, like the star Alpha Centauri, the consequences of its massive blast may be large and considerable. Remarkably, the last recorded supernova in our very own universe happened in 1604, and humanity still cannot seem to locally observe such an event. However, a great supernova did occur in 1987 inside the huge Magellanic Cloud, located 169,000 light-years away. While that event had considerable effects, it posed no imminent threat to Earth, serving as a reminder of the scale and potential impact of such cosmic occurrences. The idea of a hazard zone associated with a normal supernova is interesting and could have severe repercussions for life on Earth if a supernova were to happen nearby. Ultimately, it's crucial to remember that, in the grand celestial timeline, supernovas are highly small events compared to gamma bursts, which are vastly more powerful and represent a greater kind of risk. Gamma bursts can have devastating effects, capable of crushing biospheres and inundating planets with harmful radiation. For instance, a particular form of astronomical burst could cause the destruction of a planet's ozone layer, leaving it vulnerable to the harsh radiation of the universe long after the event has occurred. This possibility was highlighted in a recent study that introduced new potential dangers linked with the mass of stars that end their lives in a brilliant fashion. When large stars explode in a supernova, they can reach some of the brightest radiances known in the universe. In fact, the brilliance of a single supernova can surpass the combined brightness of millions of stars. This raises the question, what would the outcomes be if horrifying little creature juice were to undergo such an effect? If a supernova were to occur, scary little creature Juice could become the second most magnificent object in our sky after the sun. Shockingly, regardless of the distance separating it from us, dreadful little creature Juice, which shines more brightly than a full moon, might become visible during the day. The sheer energy of the explosion might result in a display so staggering that shadows might be cast even in complete darkness. Such a scene would both awe and astonish, demonstrating the raw energy of cosmic activities. While the visible light produced by means of a supernova is indeed considerable, it is only a part of the overall energy released during such an event. Although high levels of visible light can cause transient blindness, the greater issue lies in the high energy radiation produced alongside the visible light. This radiation often appears as X-rays and gamma rays, which can have wide-ranging effects. One of the most significant dangers posed by this high-energy radiation is its ability to catalyze the depletion of oxygen from the ozone layer, which shields our planet from harmful solar radiation. Without a healthy ozone layer, life on Earth's surface would be exposed to severe ultraviolet radiation from the sun, potentially leading to mass extinction events. In the aftermath of a supernova, different dangers arise over time. In the first minutes following the explosion, the extreme radiation poses imminent threats. But over time, large light beams and debris, moving at near-light speeds, start to travel through the solar system. These powerful beams can destroy portions of the ozone layer and blanket Earth's surface with harmful radiation, worsening the risks posed by the initial explosion. Furthermore, supernova rays carry a significant part of the total energy produced by the cosmic blast, and their long-term effects can persist for centuries. There is evidence suggesting that such events may have affected Earth in the past. For example, elevated levels of iron-60, a radioactive isotope created in supernovae, have been found in ocean floor sediments and lunar regolith. This finding indicates that Earth may have been impacted by supernova ejecta in recent geological history, possibly within the past few million years. Astronomers have already concluded that there are no nearby supernova candidates that pose an impending hazard to life on Earth based on our current understanding of the risks associated with gamma rays and supernovae. However, ongoing research has uncovered additional potential risks related to specific types of supernovae. These supernovae can release long-range lethal radiation that poses an extra threat to planets like ours. The mechanism behind this involves a star nearing the end of its life, surrounded by a massive disk of material. When the supernova occurs, a shockwave is created, hitting this disk and causing it to become incredibly hot, producing a significant amount of high-energy X-ray radiation that can travel considerable distances through space. The most radiant X-ray cosmic explosions have the ability to deplete a planet's ozone layer by as much as half, creating conditions that could lead to an extinction event within a range of about 150 light-years. Fortunately, no candidate X-ray supernovae have been identified in Earth's immediate region. But this research has led to new insights into the concept of the habitable zone in space, the area within galaxies where conditions are favorable for life. The findings suggest that this habitable zone may be subject to more constraints than previously thought. Specifically, the outer regions of galaxies may not have enough star formation activity to create the elements necessary for the development of rocky planets. Meanwhile, the inner regions, where stars form and die at a faster rate, present their own dangers. Frequent supernovae in these areas can illuminate the surrounding space, increasing the risks for any potential life that might exist there. New studies show that the inner boundary of the cosmic habitable zone is probably found farther from the galactic center than previously thought, reshaping our understanding of where life may potentially thrive. So, what would the frightening little creature Juice supernova look like from Earth? While Earth's biosphere will likely remain unaffected, the real spectacle will be hard to ignore. According to scientists, dreadful side Juice will continue to shine brightly for over 90 days following its explosion, achieving a brightness nearly equal to approximately half of that of the moon on numerous occasions and much fainter than a full moon. Essentially, it will appear as a bright point above, serving as a beacon that could be visible even during the day. Its striking brilliance will captivate everyone who gazes upon it, creating colored shadows in the night. This celestial event will undoubtedly be a source of fascination for everyone on Earth. As the cosmic explosion remains visible to the naked eye for months, its remnants will slowly fade. As researchers continue to observe worm juice, they are uncovering more about the life cycle of large stars and the processes that lead to their explosive endings. Understanding these vast phenomena is essential for gaining insights into the evolution of our universe and the creation of elements during a supernova. Furthermore, the light generated during these events contains a wide range of heavy elements like gold, silver, and uranium, which are formed under the intense heat and pressure of the explosion. This process, known as nucleosynthesis, plays a key role in enriching the interstellar medium with the building blocks necessary for future star and planet formation. Interestingly, the remnants of a supernova, known as a supernova remnant, can become a stellar nursery, where new stars are born from the dust and gas expelled during the explosion. This recurring process highlights the interconnectedness of galactic activities and shows how the death of one star can give rise to the birth of others. Scientists have identified several supernova remnants that are still forming new stars years after the original explosion, demonstrating the dynamic nature of the universe. Another fascinating aspect of studying supernovae is their role as cosmic distance markers. Astronomers use type Ia supernovae, events from white dwarf stars that reach peak brightness, as standard candles for measuring distances in the universe.